Hi grade 10s. We're just going to recap what we've done so far in analytical geometry. Done the distance formula, which is really based on Pythagoras. And we know Pythagoras says the hypotenuse squared is equal to the sum of the other two sides squared, and this was the horizontal distance plus the vertical distance squared. And so, of course, if we take the square root, because we're really interested in the length AB, that's the length of a line joining 2 points, then it would be the square root of that there. Then we dealt with the midpoint formula. And the midpoint formula was really finding the average of the two x values and the average of the two y values. So you added the two x coordinates of the endpoint of that line segment and divide by 2, and similarly 2 with the y coordinates of that line, the endpoints of the line, the y coordinates of that line segment. And then more recently we dealt with gradient. Gradient of a line segment is the change in the y over the corresponding change in x. In other words, it's the vertical difference. Now, the change in the two y values, the vertical difference over the horizontal difference. Rise over run, as you've done in previous grades. So today's lesson is application of gradient. In other words, how do we apply this formula? Now, parallel lines, when lines are parallel, they have exactly the same slope, the same gradient. So parallel lines, it's the same as saying lines have equal gradients. That's a congruent sign, means that's the same as saying parallel lines congruent to lines having equal gradients. Lines having equal gradients mean the lines are parallel. So for any pair of parallel lines, let's say AB and CD, the gradient of AB will be exactly the same as the gradient of CD. Let's look at an example. If you are given the points A minus 1, 5, B minus 2, 3, C, 9, 10, and D, 5, 2. And the question says, show that AB, the line AB, in other words, the line joining those 2 points, is parallel to CD. The moment they talk about lines being parallel, I'm going to work out the gradients. I'm going to work out the gradient of the line AB. Means I focus on these 2 points here. And we write down our formula. It's the change in the two y values over the corresponding change in the x values. So I start with YB, 3 minus 5 over negative 2 minus 1. And if I work that out, I get negative 2 on top, and negative 2 plus 1 gives me negative 1. And a negative divided by negative is a positive. So the gradient of the line AB is 2. Let's work out the gradient of the line CD. Again, there's my formula, the change in the y values of the corresponding change in its x values. So I start with YD, then it's going to be YD is 2 minus 10 over XD, 5 minus 9. So 2 minus 10 is negative 8. 5 minus 9 is negative 4. Negative divided by negative is a positive. 8 divided by 4 is 2. Notice the gradients are equal. Therefore, I can conclude the gradient of AB is equal to the gradient of CD, and therefore the lines are parallel. So I've proved that the lines are parallel by working out their gradients. Gradients are equal, therefore the lines are parallel. Parallel lines have the same slope, same gradient. What about perpendicular lines? Now, if you just look at the sketch here, you can see perpendicular lines. There has to be one running in the one direction and the other in another direction. So obviously, just from this sketch here, that if lines are forming a perpendicular 90-degree angle, you're going to have one with a positive gradient and one with a negative gradient. So to help us along here, I said when you have perpendicular lines, these two conditions will be there, that the gradients of the lines will have opposite signs. So one will be positive and one will be negative. And the gradients are reciprocals of each other. So let's look at this here. If you look at this example here, Here you can see this gradient is negative. And what is the change here? The change in the y is 3 and the change in the x is 2. So the gradient is negative 3 over 2. But let's look at this here. The change in the y is 2 and the change in the x is 3. And that's what we mean by the reciprocal. So this is 3 over 2. Yes, it's negative. We know they're opposite signs because they're running in different directions. But notice the gradient of the one line was 3 over 2. Then the other gradient would be 2 over 3. That's what we mean by the reciprocals. And if we put these two facts together here, then we can say for any pair of perpendicular lines, AB and CD, the product of their gradients will be minus 1. So note, because when we multiply a negative times a positive, it's going to give me negative. And when you multiply reciprocals, you will see that it gives you 1. So the product of the gradient is minus 1. So if we must prove that lines are perpendicular, we'll work out each gradient, multiply them, and the answer should be minus 1. But it's also easy to recognize when two lines are perpendicular, they will be opposite signs and they will be reciprocals of each other. Let's look at an example. Here in this example it says, show that AB is perpendicular to CD, and they give me the points of A, B, C, and D. So what am I going to do? It's AB I'm focusing on. So we talk about perpendicular. So I'm going to work out the gradient of AB. Again, there's my formula. So it's negative 7 subtract negative 3. Negative 7 minus 3 over 6 minus 3. So what do we have on top? We have negative 7 plus 3, and 6 minus 3 is 3. So the numerator gives you negative 4 over 3. Let's work out the gradient of CD. So it's the formula here, change in the y of the corresponding change in the x. So yd, it's 3 minus 0 over negative 1 subtract xc, which is minus 5. So on top we've got 3, and at the bottom we've got negative 1 plus 5, and that gives you 4 at the denominator. So note already I can see opposite signs. I'm on the right track, and there they are reciprocals. And let's just write formally what it says. Therefore I can multiply the two gradients, negative 4 over 3 times 3 over 4, and if you multiply that it gives you negative 1, proving that the lines AB is perpendicular to CD. Let's come to our last application. And here we talk about collinear points. Now what are collinear points? Points which lie on the same line. That would mean that the gradients between each pair of points are the same. So if you look at the sketch here, I have 3 points A, B, and C. And the gradients, if you look here, A is 2 and 4, B is 4 and 6. So the change in the y from that 4, which is that y value, and that y value 6, that's the change of 2. And the change in the x from x is 2 to y is 4, that's a change of 2. So that gradient is 2 over 2, which is 1. And if I work with B and C, if you look at the 6 and the 8, the change in the y is also 2 from 6 to 8, and the change in the x values here from 4 to 6 is also 2. So the gradient for this between B and C is 1 as well, 2 over 2. And yet when I look at A and C, if I look at those points, the change in the y value is 4 to 8 is 4, and the change in the x from 2 to 6 is also 4, and 4 over 4 gives you 1. So it doesn't matter which points you take here, which pair of points, the gradient between them will be the same. And that just proves they're all on the same line, because the gradient remains the same regardless of which pair of points you take. So A, B, and C are collinear. It would mean that the gradient between AB, the gradient of AB, will be the same as the gradient of AC, which will be the same as the gradient of BC. So the gradient between each pair of points will be exactly the same. In other words, we can separate this and say the gradient of AB is equal to the gradient of AC, We can say the gradient of AB is equal to the gradient of BC, and of course we can say the gradient of AC is equal to the gradient of BC. Why do we write this like this? It's just to say that we don't have to work with all three at the same time in our sums. We just work with a pair. And then you can see that all 3 points would have been taken into account regardless of which pair you take. Look, here's A, B, and there's C. A, B, and C. Okay. One of the points will be common to both of those gradients, sorry. So let's look at an example. So they say, show the following points are collinear. And they give you 3 points there. So we've got A, B, and C. So without having a sketch, we want to actually show that they're collinear. And of course, if we do plot them accurately, they should be lying on the same straight line. So we're going to work out the gradient between these 2 points. So you can choose any pairs. So I'm going to choose I've chosen those 2, and then I've chosen those 2. But you can go and choose BC as well. So gradient of AB. Write down my formula. So it's the change in the y. So it's y. I've chosen YB, which is 1. Subtract minus YA. 1 minus minus 2 over the change in the x, 1 minus 2. So here on top we've got 3. 1 plus 2 is 3. And 1 minus 2 is minus 1. So the gradient of AB is negative 3. Then I've worked out the gradient of AC. If I use those 2 points there, I'm taking A and C now. So I will say 7 minus minus 2. And negative 1 minus 2. So 7 minus minus 2 is 7 plus 2, which gives me 9. Negative 1, negative 2 gives me negative 3. And 9 divided by negative 3 is negative 3. Therefore, I can say the gradient of AB is equal to the gradient of AC. And therefore, A, B, and C are collinear. Now, I could have taken, as I said earlier on, BC and worked out that gradient. And if I just do it, it will be 7 minus 1 is 6, and minus 1 gives you minus 2, and 6 divided by minus 2 would give you minus 3. So we could have also taken that pair there as well. So to prove points are collinear, you take any pair of points, and you take another pair of points, and you show that they are the same gradient, meaning that they will be lying on the same straight line.